Alright, so let's move on to the next chapter. It's going to be chapter 5 that's on relations. Alright, now, fun fact here is that you have studied lots of relations in your mathematical career. So, as we continue to go through more topics in the class, you realize that there's a lot of things that you've learned in math, and now we're just trying to abstract them a little bit and try to see how are they related in maybe ways that you never thought were possible. So, for instance, the idea of sets you studied, and you studied functions, for instance, and those are very closely related. So relations is something that you have studied a lot of, and so some examples of relations would be something like equals, right? So how is one variable related to another variable? Well, a way to relate them could be equals. You could also have the same thing with less than. For instance, less than is a perfect relation. How are things related? Because of this. Or you could do greater than, or you could do less than or equals, or greater than or equals. These are all examples of relations, of trying to see how is one thing related to something else. Now, in this class, another topic that we've studied about relations would be, another example would be, say, A is related to B if A divides B. So you could talk about this relationship. So not in just a numerical standpoint of comparing numbers, you could do this as statements about some type of property. So you could say that this relation is described by A dividing B. So we're going to, if we notice with all of these, there's going to be pairs of objects. So we're going to be comparing numbers, or we could be talking about this being related to this, or you could talk about people as well. You can talk about anything. And so we're going to define relations as pairs of objects. So again, we can talk about this as an abstract thing. If we could have letters, animals, words, anything, numbers being the objects, we're just going to look at pairs of these. So the definition that we have of a relation is, so if we have A and B are sets, a relation R, so R is going to be what we define a relation by. R is our relation from A to B is going to be a subset of A cross B. So automatically, you should have some little sirens going off on your head of, ooh, wait a minute, I've seen something like this. Hopefully, you do remember something else like that. What else have we looked at that is a subset of a Cartesian product? That is indeed functions. So there is going to be a relationship that we're going to get there between relations and functions. But let's get back to this definition. So we're defining this relation as a subset of a Cartesian product. Then if little a is going to be a subset of, or an element of this capital A, and little b is going to be an element of the set B, we're going to write A is related to B. So A, R, B, if this ordered pair of A comma B is an element in R. So remember, so if we have elements in a Cartesian product, these are ordered pairs. So what we're talking about is if we have this ordered pair of A comma B, if that is in our relation, so if that's in this, however we're defining this R, that means that A is going to be related to B. And then vice versa, then we could cross out, do a little slash through the R and say that these are not related if this ordered pair is not in R, not in our relation. And then just as a note here, we're going to be dealing a lot with this, is the very special case that if we talk about A being mapped to A, so instead of A and B possibly being different, we're going to say, what if we're forced to have those be the same? So relation from A to A, we just simply call that a relation on A. So in that case, elements in both the first and the second position of our ordered pairs will come from the same set. All right, so let's take a look at an example here. So if we have our set capital A, B containing the elements A, B, C, this capital B be the set containing 1, 2, and 3, we could define this relation. So remember, this is a subset of a Cartesian product. Within that are elements that are ordered pairs. And the first number in this, this first element here is going to be an A. So this would be an example here where R is going to be a relation from A to B. Or maybe we'll ignore that notation for right now, but we'll just say, indeed, if we're thinking about it just being the same as here, we'll assume that these are going to be elements of the first, and these are going to form the second entries. So we can ask, is A related to 2? Well, to see if they're related, we're looking to see, is that ordered pair in there? So is A2, so is A2 an element of R? Well, yes, obviously you should see this. So yes, it is. So in this case, A is related to 2. Is A related to 3? So is A comma 3 an element of R? Well, no, obviously. So this one is B1 in this? Well, yes, these are related. And then is 2 related to A? Now, what we're asking here is 2A an element of R? Now, notice here is that we have to be very careful that the order here does matter, because 2A is not in this, but A is related to 2. So this is going to lead to some really interesting discussions in a couple videos from now, discussing how you can have A is related to 2, but 2 is not related to A. So it is not going to have this really nice commutative property, or we're going to use a different word in this class, but it's not going to be able to switch freely of what is related to another thing. And that should make sense, right? If we think about some of the relations that we've looked at in the past, something like less than, for instance, you could say 1 is less than 2, so they're related with the less than, but 2 is not related to 1 because 2 is not less than 1. So this is just a little bit of an introduction of getting into some of the notation and some of the basic ideas behind relations and how they are related to Cartesian products.